following are the steps for graphical analysis of data. Number 1, identify which set of data is the independent and which set is the dependent variable. Remember, independent variable is going to be the one that you can manipulate and change, and dependent variable will be the one that changes as a result of changing the independent variable. Next, determine the scale to use for each axis. So if the largest value is, say, 40, then you would take 40, and your grid lines are 10, you would take 40 divided by 10, and that would mean that you would use 4 points per grid line. Plot your data on the graph. So we're going to, once you have your grid line set and you have your axes labeled, you're going to plot your x and y, or independent and dependent variable, accordingly to get your shape. Sketch the best fit curve, or best fit line or curve, which what that means is you'll start to see a pattern, and it should fit one of the patterns that we have discussed before. Number 5, identify the shape of your graph from the models to identify the modification. So if it's a curve, you'll want to do a modification to linearize the data. Next, perform the modification on the correct data set. So if you need to square the x values or the independent variables, you would square them. If you need to take the inverse of the x-axis or independent variable, you would take the inverse of that. Do whatever it tells you to do from step 5, which is identify the modification. Step 7, rescale the axis on the graph to match the adjusted data. When you have new data, the values may be a lot bigger. They may be some of them may be smaller, but you're going to have some adjusted data. Sometimes you won't have to do very much on the axis. A lot of times you'll have to make slight adjustments. Next is to plot the adjusted data, and then which should be a straight line. Then sketch the best fit straight line, find the slope, the rise divided by the run, and then finally write out the mathematical relationship of the data set. You should not use x and y on this part. It needs to be needs to trace back to what your independent and dependent variables are, and you need to say, for example, that pressure is equal to 1 over volume instead of y is equal to 1 over x. So keep those in mind. And now we're going to do the steps. So here we have data set number 1. So on data set number 1, we're going to graph volume and pressure. Volume is going to be our independent variable. Pressure will be our dependent variable. So our data set goes from 0.1 all the way down to 10. Our pressure values go from 40 all the way down to 0.4. So first step is to label our x-axis. So when you label our x-axis, or our independent variable, you see that it is volume. So I'm going to write on here volume. Okay. Next, I'm going to go ahead and label my y-axis, which is pressure. And so when I label pressure, I'm going to write pressure on this side. And now I'm ready to scale my x and y axis. So as you can see here, the largest value for my x-axis is 10, and my smallest is 0.1. So I can start at 0, and I'm going to go all the way up to 10. Now, because there are 10 grid lines going across, I'm going to scale it accordingly. So just to kind of do a quick calculation, you do 10 divided by 10, which obviously is 1, but what that tells you, though, is that each one of these grid lines is worth 1 meter cubed. So I'm going to go ahead and write those out on my grid lines. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, my next one is to do that for pressure. And for pressure, as you see, the largest value is 40. And I still have 10 grid lines going up, so it's 40 divided by 10. So each grid line is worth 4 pascals. So I'm going to write that out on here. So it's going to be 4, 8, 12, 16, 20,
Attention students, when the bell
24,
rings, please report to your
28,
homeroom class. When the
32,
bell rings, students, report to your
36,
homeroom.
and
Teachers,
40.
please check your mailboxes this morning for new schedules. Again, teachers.
Now that I have my pressure and volume scaled out, I'm going to go ahead and plot out my data points. So when I'm plotting out my data points, I'm going to start out with the first one, which is going to be 0.1 and 40. 0.1 and 40. So I'm going to put 0.1 and 40. 0.1 is going to be over here, and 40 is going to be all the way at the top. So I'm going to put my first point right up there. My next one is going to be 0.5 and 8. So 0.5 is in the middle, and then 8 is going to be right here. So here is my next data point. Next one is 1 and 2. So we're going to 1 and 2. And then I'm going to go 4 and 1. 4 and 1. 5 and 0.8. 5 and 0.8. And 8. And then as you can see, it gets closer and closer. The next thing I'm going to do is I'm going to try my best to draw the best fit curve for my data. So I'm going to start at the top, make this a little bit smaller. Start at the top and try to curve it and make it look like that. Okay. So now I have my data set and my curve, and now I'm going to compare that to what I have. So if I look on my cheat sheet, I can see that here is this. It matches up best with this curve, which is an inverse curve, because you can see it kind of starts at the top, it curves back down. It starts up here, curves down. So it's an inverse proportion. So the correction is I'm going to keep my y the same, and I'm going to adjust my x values by taking the inverse of my x values. Since I know that my correction is going to involve keeping y the same and changing my x values to the inverse values, I'm going to go ahead and start doing that. So I will put a line across here like this, and over it I'm going to indicate what is the correction I made. And it's 1 over v. So I'll start out with my first one, which is 1 divided by 0.1, and that will give me 10. And so I'll put 10 right here. All right, then the next point is you're going to take 1 divided by 0.5, and that's going to give you 2. So I put 2 here. 1 divided by 1 is 1. 1 divided by 4 is 0.25. 1 divided by 5 is 0.2. 1 divided by 8 is 0.125. And then 1 divided by 10 is 0.1. Now I have adjusted my scale. I made it 1 over v. So my next step, after I made it 1 over v, is to come over and scale and label my x-axis and scale and label my y-axis. Now, my x values are now going to be 1 over v. That's my new label because that's the modification I made. And I still have the same scale because, as you see here, 10 is still my largest number, and my smallest number is still very close to 0. So I'm still going to scale it as a 1-to-1 ratio. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we label and scale out our y-axis, which includes our pressure, and we'll put on here pressure, and I'm going to call it P, and then I'm going to just keep the same scale I had before and just call it 4 8, 12, 16, 20, 24, 28, 32, 36, and then finally 40. So next I'm going to, after I've done that, I'm going to go ahead and plot out new points that I have. So I will start out with 10 and 40. So 10 and 40 are going to be here. Next is 2 and 8. 2 and 8 are right here. Then 1 and 2. 1 and 2. And then finally 1 and 2.5. 4 and 2.5 and 1, which is going to be close. Now notice everything's kind of getting crunched up here, so you're not going to be able to finish up the data. So now you got to take a straight edge. So when we take our straight edge, we're going to draw our best fit straight line, which will look something like that. And now we find our slope. So to find the slope of this, we're going to take our x-axis, or we're going to take 2 points that cross a grid line. So we're going to say take this point right here, and we're going to say take this point right here. So we're going to find our rise and divide that by our run. So our rise is going to go from 12 and go on up to 28. So 28 minus 12 gives us a rise of 16. Then we're going to find our run. Our run is going to go from 3 and all the way up to 7. And we're going to take 7 minus 3, and that gives us a run of 4. So our slope ends up being 16 divided by 4, which gives you 4. So now we finally write out our equation. So putting it all together, you can see here that it's y is equal to m times 1 over x. Y is equal to m times 1 over x. So instead of writing y, I'm going to write down what my y-axis is, which is p. So I'm going to write down p. All right, so instead of putting y, I'm going to put 1 over x, and y and 1 over x, I'm going to put down what I have for my dependent variable, which is pressure. So I'm going to write down pressure, P, and I'm going to say equals to the slope, okay, because it's m. You see here that's y is equal to m times 1 over x. So m is my slope. My slope is 4, so I put down 4, and I'm going to multiply that by 1 over x, which x in this case is v, and my final answer is p is equal to 4 over v, and there is my final answer.